To today's lesson on interpreting bar graphs. In this video, we'll look at some examples of bar graphs and learn how we can interpret them to get some valuable information. Without further ado, let's jump right in. For our first example, let's take a look at a bar graph that shows the approximate heights of some of the tallest mountains in the United States. What are some things that we notice about the bar graph? Well, there are two axes in our graph, the horizontal axis and the vertical axis. The horizontal axis, which sits at the bottom of our graph, tells us what our data represents. In our case, the data represents the different mountains in the United States. Now, looking at our vertical axis here on the left side, we see a list of numbers. These numbers show the different levels of elevation from 15,000 feet to 21,000 feet in steps of 500 feet. Now, you may be wondering, why does the elevation level in our vertical axis start at 15,000 feet? Well, notice that our bar graph includes a squiggly line on the vertical axis. Why is this squiggle here and what does it mean? Well, this squiggle, sometimes called an axis break, is here to show us that the range of heights of our mountains doesn't start at 0. Instead, the bar graph only shows the range relevant to our data, which starts at 15,000 feet. In other words, all our mountains are taller than 15,000 feet, so there's really no point in showing anything less than 15,000 feet. Now, how do we interpret this bar graph? Well, for vertical bar graphs like this one, you can imagine that the vertical axis is like a giant ruler that can measure the elevation of mountains. And each of our bars in the bar graph represents the height of that mountain. So we can use this ruler to measure how tall a mountain is by drawing a line from the top of any bar to the vertical axis. Okay. Now let's use our bar graph to answer some questions. First, what is the height of the tallest mountain in our graph? Well, we see that the bar for Mount Denali is the tallest, which means that Mount Denali has the highest elevation. Comparing the top of the bar to the vertical axis, we can see that Mount Denali has an elevation of 20,500 feet. So our answer is 20,500 feet. Okay, let's use this bar graph to answer another question. What is the height of the shortest mountain? To find the height of the shortest mountain, we have to look at the shortest bar in our graph. We see that Mount Bona has the shortest bar. Comparing the bar to the vertical axis, we see that Mount Bona has an elevation of 16,500 feet. So our answer will be 16,500 feet. All right, let's take a look at another example. Let's say that our friend Dan, who loves to run, records the number of miles he ran each month. This bar graph shows the distance Dan ran in total for each month from January to May. Now, you may notice that our bar graph looks slightly different from the first one we looked at. That's because this is a horizontal bar graph. A horizontal bar graph is just like the vertical bar graph we looked at in our first example, but turned on its side. Now our categories are listed on the vertical axis, and our line of measurement is on the horizontal axis. Also, our bars will extend horizontally from left to right. So, using this bar graph, let's answer a question. How many more miles did Dan run in May than in April? To find out, let's write down how many miles he ran during each month first. In April, Dan ran 12 miles. And in May, we see that Dan ran 22 miles. To find out how much more Dan ran in May, all we have to do is find the difference. So we'll take 22 minus 12, which gives us 10. Dan ran 10 more miles in May than in April. Okay, now let's move on to our last example. One day, our friend Dan asked all the 7th and 8th graders at his school which of these sports they liked the best: basketball, tennis, volleyball, or soccer. His results are summarized by this bar graph. As you can see, this bar graph shows the 4 sports on the horizontal axis and the number of students on the vertical axis. But you may notice now we have 2 bars above each category. This type of bar graph is called a double bar graph. Right below the title of our bar graph, we also see a legend. The legend explains what the 2 colors of our bars mean. In our example, our legend shows us that the 7th graders in Dan's school are represented by the orange bars and the 8th graders by the blue bars. Knowing this, we can use this bar graph just like any other bar graph we've looked at. In fact, we can even use this double bar graph to compare 7th and 8th graders' opinions. Now, let's answer some questions. In Dan's school, did more 7th or 8th graders say tennis was their favorite? Looking at the bars above tennis, we see that the orange bar is higher than the blue bar. So we know that more 7th graders than 8th graders said tennis was their favorite. Moving on, how many more 8th graders than 7th graders said volleyball was their favorite sport? Well, let's take a look at the bars above volleyball and compare them to the vertical axis. Doing so, we see that 23 8th graders and 21 7th graders said that volleyball was their favorite sport. To find the difference, we'll take 23 minus 21, which gives us 2. So we know there were 2 more 8th graders that said volleyball was their favorite. What if we wanted to find which sport was most popular among the 8th graders? To find out, we just have to see which of the blue bars is the tallest. Comparing all of our blue bars together, we see that the tallest blue bar in our graph is the bar for basketball. So the most popular sport among the 8th graders was basketball. Now, how many more 7th graders chose tennis than chose soccer? First, let's compare the orange bar for tennis to the vertical axis. We see that 24 7th graders said tennis was their favorite sport. Doing the same for the orange bar for soccer, we see that 20 of them liked soccer the most. The difference is 24 minus 20, so 4. 4 more 7th graders chose tennis than soccer as their favorite. Alright, and that's the end of it. As you can see, bar graphs can be used to tell us a lot of information in a neat and organized way. We can see how tall a mountain is, or how far someone ran, or even compare how 7th and 8th graders differ in their favorite sports. So with that, congratulations! You are now ready to read and interpret bar graphs. See you next time!